Welcome, everybody, to the latest E5 podcast. I'm your host, and I'm joined by my wonderful tag team partners. Please introduce yourselves.
Hello, I'm JW.
Hey, it's Dave Watts, aka Sparky Ninja.
And it's us again talking about random electrical things that we love dearly. We thought it's been a while since the last few, so we thought we'd do another few because it's pointless doing it weekly because you just get bored of the sound of our voice. But today we're going to do something a little bit special because Mr. Watts, we are going to talk about electric vehicles and electric vehicles in many, many forms. And you're going to take the lead on this. Now, I just want to add my bit because I have always been cynical on EV, as has John, although I think we're all qualified in the subject matter. I did my sitting guild, was it 2919 or whatever? I can't remember. The old one.
Yes.
Thinking I'm now qualified, and then literally the week after I did it, the sitting guilds announced they were withdrawing that qualification and introducing a 3-tier qualification.
Yeah.
But I am, for the interest of transparency, I'm a Garrow approved installer.
Oh, well, there you go.
Even though I've never installed Garrow, and I did it all online during COVID. But yeah, there you go.
Yeah.
Anyway,
and all that Garrow stuff, by the way, online has all disappeared now.
Has it?
So you can't do it anymore. So there's the thing.
Okay. So that's the
not
bug you a little bit there, Paul.
installer anymore. Oh, woe is me. It was, to be honest with you, it was farcical. The whole thing was farcical. I remember doing it while I was doing something else, and it was not very good, to be honest with you. Not very. EV is quite an interesting journey of competency development because we've sat and watched it be, I don't know what the word is, random, changing, evolving, developing. John, what's your thoughts for Dave kicks us in the nuts with his feedback?
Yeah, well, that qualification thing, I was done over with that as well because I did the old one, and then oh no, that's not available anymore. It discontinued. So now there's some other stuff. It's like, well, yeah, thanks for that. Big pile of waste of money and time there. And I think a lot of that online training gubbins, which came around some years back, was all due to the government grants thing, where they initially said, oh, if you want to be approved to install this, and the rest, you have to be approved by this manufacturer and that manufacturer. So they all sort of rushed in and tried to cobble up some kind of scheme you could just go and watch a few videos and answer a couple of questions on. And I think that's where most of that came from. And that's probably why most of it's gone away now. So, I mean, in some ways it could be useful, but a lot of it was literally just a ticking the boxes type of exercise. So
it has
been
useful. It's been quite fun watching the EV journey, isn't it? And different manufacturers slandering each other, although we can't officially say that, but they have been. But Dave, you have been teaching this, all 3 of the new qualifications.
Yes.
Do you want to tell us about them?
So, yeah, first of all, it was just City and Guilds that introduced 3. The other awarding organisations kept it at the 1. The difference with them is, if you've got an installation of an EVSE that's what we refer to the chargers as, that is greater than 22 kilowatts, basically. That's where they recognise that there was a different requirement in the design. There's a different requirement in the actual setup. So they split it into 3. So the one that you did, that I did, these other providers and stuff. I remember my one. That was interesting. That was the 2919. What they did is they shelved it because, again, remember, there was an audit that went around and they looked, because all this government money was put into this strategy, and there was an audit, and they concluded that a lot of these weren't being installed properly because there's a lot of poor standards, poor reporting, poor installations generally. And then TESP have introduced this Electrician Plus model, and it's now being pushed for all other qualifications that are supposed to be Electrician CPD qualifications. The battery is being relaunched as Electrician Plus. The solar is being relaunched as Electrician Plus. There are going to be requirements for registration with CPS in the future as well, but they've got to be Electrician Plus delivered. And Electrician Plus just means that you have to be recognized as a level 3 qualified electrician by the provider. And when we register you, we have to submit this proxy, which just says, yes, we have done all the checks and we are going to verify that you are a level 3 equivalent. It's just happened to the 2391 as well. Some providers aren't quite aggressing with that, because it does mean the pool of learners potentially has significantly shrunk, but it's definitely for the better. But what City and Guilds did is they brought in 3. One was just a replacement with a slight update of the old 2919, which became the 292134. 292134. I guess that's what it is now. And then they introduced the 292132 and the 292132, which is the installation and maintenance of, and the design and quality assurance of, and it's large scale. And that's been the interesting journey for me, because it was quite an interesting qualification. I'm going to highlight some little parts of the material that we use, and we identified that the maths that's involved in the assessments was quite new for us. Remember we did some old videos with Paul where we had these like regular chats about, to determine ZS, we shouldn't add R1, R2 to ZE.
Yeah.
So we don't do that in the large scale. We actually do Z1 plus Z2. So we do a little adjustment using reactants, and we actually use more of the regs, which is interesting, and some other bits of another technical document. And that kind of, I think, alienated an awful lot of providers. I remember when I was in the initial webinar that City and Guilds hosted with some of the technical authors of the book, the number of people who were in the webinar suddenly went down, and there were a lot of comments about, oh, this must be level 4, this maths, this is quite complicated stuff. It just looks horrific, but when you do it and you do it and you do it, it does make sense. But it's just really doing what the software is doing.
But is it fair to say then, Dave, that there is a mindset in industry of give me a wire, give me a box, make it simple, I plug it in, I connect it in, and as hard as it gets, it should be an app? Because loads of electricians do their designs now off of apps and still rule of thumb stuff. But what you're saying is you teach 3 levels of EV design. So it's domestic or dwellings. You then you've got the commercial grade, and then the larger scale stuff like your electric trucks, your big, like what Tom Nargy's doing at the moment, 150 kilowatt truck sort of stuff. And
so we it started off basically over 22 kilowatts, so we went into the area of 75 to 150 when it was really launched. Then we're at 360, but now we're looking at megawatts. We now have installations of megawatt systems, 1 megawatt, 3 megawatt for HGVs. These are basically, there are trials of these around the country as well. We've got pantograph systems as well coming in to try and keep things in motion. So there's also, quite complex, but even the domestic small end stuff, I see a lot of people online, a lot of content coming online, and even the basics of separation of earthing systems and simultaneous contact assessments, that they're not doing it right. They're just connecting a cable to a socket. That's all they're doing. And I don't know if I don't really know if we want to go down this direction in this podcast, but there are challenges with if an EV charger is actually a product that you could just buy, install, and commission without having to do any more due diligence. Because it does say in the regs that we need to get the declaration of conformity sorted out, and there's all that to do as well. Most installers don't do that. They just buy it, put it on the wall, connect it up, turn it on, move on. But 61851 standard isn't complied with by most chargers, not fully. Okay, so there's an awful lot of stuff in the domestic sector as well that we're still not quite getting right. We have the new Open Pen standard. As well, which we're waiting to see how most manufacturers implement that, because the Open Pen standard, the IET01 standard, it's got offerings of ways to achieve it, but as we all know, Open Pen protection isn't a 100% guarantee. We can monitor the voltages between line and neutral, looking at the peak, looking at the low. We look at the voltage of true earth, but in a distributed 3-phase system in a street, you can easily have a scenario where you don't have that voltage within the range, because it could be the second phase that's within those peak voltages, and the voltage of true earth may not reach 70 yet. So there is that little space which the Open Pen standard has identified. So we're not completely there with Open Pen protection in EVSE. We're not quite there. So shall I share my presentation? Just go through some little bits.
Yeah, go through some bits while you're doing that, John. So I don't know if you've read IET01 yet, but when I first looked at the draft, my initial thoughts were this is 4 British or BSEN standards cut and paste into one badly. That's what
Yeah,
I read bits of 61008, 60898 in it, 61009. It's just a hybrid.
It,
Someone's just thrown stuff together.
it's
yeah,
funny you say that because I looked at it. I
it's
thought it's just
rushed.
like it's like a scrapbook. On what it
Yeah, I mean
was.
the whole concept of what they're doing, this checking the voltages between whatever, is fundamentally flawed because it only works in certain situations. Because, like you just said, I mean, you can have circumstances where your voltages are correct, but it's still dangerous. So
Mm.
it's useless basically. It's completely the wrong approach. But probably should deal with that as a separate thing at a later time. Otherwise, we'll be
Yeah,
here for hours. But
yeah, it's like it's too long to tear into that standard and that whole thing. But yeah, there's a couple of interesting areas. So I guess the first thing I'm going to quickly scan through this material just to get to some key areas that we do focus on.
For
We have
those who are listening, Mr.
yeah,
Watts has got on the screen some of his marvelous EV charging standards and training material, which I'm looking forward to attending one of those courses in the future. You do some quality stuff, Dave. You really do. I mean, it's so easy on the eye. That's one thing I love about your stuff. It's just beautiful on the eye.
it's an awful lot of work. I'm right now working on my level 3 2365 stuff. I'm trying to get that remastered because the City and Guild stuff is just not very good.
And there's no better compliment than seeing some of your images in there as well. It's just awesome.
Yeah.
I'm always on the lookout for good training images for you, Dave. Now, always.
And as you can see, they get used. If they're that good image, they do get used. So yeah, this is the image that me and John have just kind of alluded to with regards to the changes of open pen. This has been recognised as one of those little issues, but this is more of a domestic challenge. But large scale challenge. Let me all right, we'll brush past 61851 because that's a whole other area. But we cover all sorts of stuff on the large scale courses. But this is where the fun begins. So we have this the challenge of reactants in systems. Okay, so most electricians, when they do designs or cable designs, they do the regs course, they do inspection testing, IB, IN, IZ, calculate IT, work out volts drop. Even when they're working on the 2396, the designs really are just for small systems, lighting, power, submain. Nothing is big. And they'll just use software for everything else. And what we highlight in the large scale courses is that we need to identify the concern of reactants with our circuits. So when you look in obviously Appendix 4 in the regulations and you go to a cable sizing, when you go to like the volt drop columns, you'll see that when you get to 25 mil and upwards, you don't just have a single value, you then have three. You've got your resistive value, your reactive value, and your impedance value. And we actually then at that point, when you get to that grand size, we have to then start taking those into account. So with large scale, we have a huge amount of power. So with that amount of power, we have, especially if it's AC, we have a likelihood of reactance. And so what we cover in the course is we cover reactance. And this is just a little preview of what the formula looks like. So we have this. Now, this is actually it's now in the latest IET code. It was added in the latest. It was added to the latest IET code because of this course as Appendix M or N. It's in. You'll get these formulas in the IET design guide. In the back, I think it's section D. Yeah, in section D. The one that I'm showing here is just where we're using the armor as a CPC. So when we have a conductor greater than 16 mil, we have to consider the impact of reactance. And in this formula, it's just the armor that's being used. There's another one that we also use in the course where we have a parallel conductor. But we have this conversion of R1, R2. We have to get Z1 and Z2.
Right, so we've gone from ZS equals R1, R2, R1 plus R2, and over plus
And
ZE. So that resistance with DC and the AC test, which just should not work, but just conveniently is a mathematical veil of illusion. Lots more harsh words, Mr. Skirmer say. So we now have Z1 plus Z2. So is Z1 what have we got as defined as Z1 and Z2? Is that the parts of the circuit at different points? So the supply origin and then at the end of line?
So Z1 and Z2 is basically, it's like what we think of an R1, R2, but it's including the reactance within the system.
Oh, so the CPC and the armored equivalent
Yeah,
then.
yeah. So
Ah.
what we do with R1
Mhm.
is we consider the correction for temperature. And then with R2, we consider the correction for temperature, but there's also reactance to account for if the cable is big enough. And there's also this magic 1.1 number in there, which when we had this formula come up, we're going, what's this 1.1 about? What's this 1.1 about? And I remember watching the one of the videos, and Graham Kenyon was doing the presenting, and he said it's called the magnetic effect. And we are like, where's that come from? We looked for it in guidance note 6, where there's more guidance on this, and we couldn't really find anything concrete. But he did say one of the cheap ways to get around this is to multiply length by another 5 to 10%. And that's technically what this 1.1 is doing. It's a 10% multiplier because we're actually getting another 10% of the conductor. Okay, so we're multiplying it by 10% of itself. So it's kind of like,
So
yeah,
R1 plus 1.1 of R2.
yeah. So one
Okay.
and another 10% of it. So we're adding 10% to R2. Okay, but we're also going to add to this temperature correction as well. So in the case of the DC resistance of the copper, we have the 1.2 that we're familiar with,
Mm.
but also with the steel, we have 1.225 for the steel armor. Now, the data for that is given in the design guide. It's also given in BS 5467. It's not in 7671. So we have to collect data from the design guide or BS 5467, but they have now started putting it into the latest IET code of practice. 7671 doesn't have this data.
Why is it not in 7671? Surely that means we have to, if we're doing this, buy more bloody books.
Well, this does justify that 7671 needs expansion, but to be perfectly honest, 722 doesn't really cater for large scale EV that much at all.
Right.
Other than saying what mode 4 chargers are and how mode 4 chargers achieve protection to some degree, there's not a lot that 722 has that caters for mode 4.
I don't know what John's thoughts on this, but my thoughts on this is 7671, especially now we're seeing like Amendment 4, it's becoming what you could call, if to steal a railway term, a minimal viable standard. So it's the absolute minimum you need to think about or consider, but by no means is it the end of the journey, because you're all right, 722 for large scale ain't worth a.
Not really. Yeah, which is one of the interesting things that I found.
John, what are you
I
thinking?
mean, well, 771 is needs a massive overhaul, basically, in a lot of areas. But the problem is all this new stuff, which like EV charging, it was never in there, and it's been sort of tacked in at the end in a little appendix or a little extra section or whatever, which is really not good enough because you can't add in the quantity of stuff in like 4 or 5 pages of extra text. Not going to happen.
No.
And then things like this. I mean that ZS equals R1 plus R2, and it was never right anyway, technically, but it just so happens to work for small size conductors in a lot of situations, which is why it was touted around as a thing. But it was still wrong. It just wasn't wrong enough to cause problem. But obviously, when you get to bigger conductors and higher loads, it's completely wrong, and basically might as well not bother.
Yeah, I mean, you're exactly right there, John, in that small conductors, 60 mil and smaller, the reactance makes literally negligible difference. And even in the City and Guild project that we do as a formal assessment, the design that they have as a model is a very low end of the large scale. And even there, the reactance makes piddly squat difference. But obviously now this space has gone on so much now that reactance is taking account into these bigger systems where we've got maybe 2 times 240 mil cables in parallel and so forth. But you're right. I mean, older systems and final circuits, it makes no difference. But the IT design guide does have this stuff in it, but it's just in a section at the back in I think it's Annex D, which is just like other calculations. It'd be nice to kind of get more use. Yeah, further cable calculations, the section's called. But it's good to explore them, and it's good to see how they get used. And I'm trying to bring them into the design course, the 2396. This stuff is technically beyond the 2396 because the 2396 never goes to this level where we have to look at reactance calculations in all the history of all the papers that I've seen. Now, I'd like to, and again, on my 2396, I have on-demand videos where I go through this as extra, but I can't do it as a fundamental amount because you'd be doing too much for them to do their exam. But we don't go down that far. The 2396 just focuses on small power circuits and one submain. So So there's a model in this course presentation. I go through a few examples, but in the presentation there's this one. We get the data for an example from the table. This is table that is in the IT design guide, and it's now in the EV code of practice. This includes the DC resistance of armor with regards to the number of cores. So we have the column on the left is the size of your live conductor. Then we have the copper and aluminium cable. So that basically, that left hand is the same as the resistivity of conductors for DC resistance.
So the DC resistance of armor.
DC resistance, yes.
Not AC resistance of armor, DC resistance of armor.
We have the DC resistance R. We then work out the reactance when they're large enough. And then we do the square root. Z is equal to the square root of X squared and R squared. So we turn them into an impedance, which is AC, when we apply the reactance. Yeah?
No, well, this is kind of just saying what we've been saying for a very long time. That whole ZE, R1, R2, ZS, the dead test of DC and live test of AC can't mathematically work out and equate unless the magic maths fairies make it equate. But
I think John hit it on the head where really this is only going to become a problem with reactance when the conductors are large and the power is large, or the frequency is large, where there's huge amounts of inductance. You know, so here's a little model example that we go through. We go through this example that I've got, and by all means, if you're watching this on YouTube, you can pause it and have a go before I go. I'm just going to fly through this, but we've got here an example of a 2-core 90-degree thermosetting cable, steel or armor, but we run it at 70 because we run all systems at 70 degrees if the equipment we connect them to is 70 degrees. We have a run of 17 meters, a ZE of 0.14, an IB of 28.26 on a C32. Just general information. And we crunch that. We crunch that to work out what the actual value will be. So we get the rating, the temperature adjustments, which is obviously 1.2 for the copper and 1.225 for your steel. From table 44A for this arrangement, we have a 4 mil. That's because that will pull 28.26 with that method of installation. Then we start to get creative. So we look at this formula and we want to break it into two parts. We break it into the resistive part and we break it into the reactive part. Now, the reactive part in this case is fairly simple because it's quite a small cable. So the reactance in this case is just going to be the 0.3 on itself. But we look at the resistive part. We find the DC resistance of R1, which is a 4 mil conductor. We find the DC resistance of R2, which is a 2-core 4 mil. So if we look at the previous table, we would go, okay, 4 mil, 2-core, 7.9. Yeah. And if we find that as a DC resistance. So we've got, just jump to here, 4.61 and 7.9. That's the R1 conductor resistance. That's the R2 armor DC resistance. We have to apply adjustments for temperature to run them to ZS, because at ZS, they'll be at running temperature. So we just take this formula and we break it into two parts. We have the resistive part here, R1 plus 1.1 R2, and then the reactive part is just this 0.3 here. So we break it into two parts. First, we'll do R1, which is 4.61 times the copper correction temperature of 1.2. And we'll add that to 1.1 times 7.9 times the correction of 1.225. Boom. Like that. So that's R1, that's R2. And those two combined is the resistive value, just the resistive value. We work out the reactance, which in this case being just 4 mil, you'll notice all the cables, there's no reactance till you're over 16. So in this case, because it's just a armor, we still consider the 0.3. And there is a reason for this. And it's even cables as small as 2.5, the equivalent size of an armor is actually justifiable for reactance. This is something that we've clarified with the IAT about this. And we're supposed to even be working at reactance even when we use cables that are under 16 mil, if the armor equivalent is greater. You know, which is why they've been using this as a model in the assessments. There's no multiplier for it though, because there's no actual cable that's reacting here because it's lower than 16 mil. So it's just 0.3. We work out their overall value times their length of 17 meters over 1,000. Gives us that 0.28, gives us that 0.0051. You can already see the magnificent addition that's going to make. Absolutely sod all. Yeah, which is why we've been doing it the old way. For cables this small, the reactance makes negligible difference. Now we go in the classroom, we go through bigger cables, we see bigger examples. I just don't have any in the presentation. I do it in the handouts. And it starts to really take into effect when we go to cables that are about 240 mil. That's when it's really going to start having some fun and changing the values quite impressively. We add those together, square them, square root them. That's how we get the Z. So the Z is the square root of R squared plus X squared. That's the way we calculate impedances. It's the old triangles. Yeah, go back to your college days. Add that to ZE, gives us 0.42. 0.42 is our ZS. We have a C32, so we can apply the U0 times C min for the minimum amount of current to make sure the minimum amount of current available will disconnect the device. And that's how we verify the live conductor and the reactance in that circuit design. So it's already something that's outside of our comfort zone in this area, but it's something that we've been told will start to be pushed into some of these other courses that electricians do. It should even come into the apprenticeships.
So just ugh. So now's a good time to abandon ship, folks. My God.
Yeah.
Wow, John, has your brain just melted out your ear like mine just did? Or wow.
It's not too bad. I mean,
Repetition.
The thing is, although this is new in the scope of this, it's not actually new at all. It's been around forever, but it's just one of those things that, like you say, for smaller circuits, it was never really bothered with because in most cases it didn't make a difference. But when you're dealing with massive sizes like with huge loads for EV charging, it definitely does.
And that's I think what it is. It's because we've got long lengths of cable and we've got big conductors and we've got large loads. And I think that's why this has become much more of a requirement in this course, particularly, is why they brought it in and they brought in these formulas. As John says, the formulas have always been in these older standards and in the IT design guide. We've just never used the book enough to reach that end of the book or to go that far with our application. Even though technically we are supposed to, even when we're, even in this case, because there is a reactive component, even if it is negligible. Software does do this, but as they said, we need to make sure that we can interpret and we can question if the software does it.
Yeah, and the other thing here is the temperature, because in a lot of circuits, they never ever run at their maximum temperature because they never loaded up that far. But of course, EV stuff is always loaded up to the max.
Yeah.
So of course, it's going to run at high temperatures. That's just inevitable from how it is. So
which
somewhat different.
Which creates some more of these problems is that we've got to look at how we're designing things now. And lots of these installations for large scale, they're going in and no one's using them because they haven't obviously brought in all the EVs yet, But, and I've said this when I've done the courses, is when we look at the maintenance that we apply, we initially will do a lot of maintenance to make sure it's working safely. Then we normally would relax the maintenance. But here, we're actually going to put something in that's not going to get used for 2 or 3 years to its full capacity. So we should actually be a lot more reactive to the increasing in demand. A lot of large-scale EV that's been installed in the country isn't technically compliant. It doesn't comply with 7671 at all. None of it does. All right? Because they can't follow 7671 for reasons we're going to go to next. They just can't do it unless they do an awful lot of adjustment for factors where they kind of abandon the way it works.
It's quite interesting because I think Mr. Nagy has just installed some 150 kilowatt chargers for these new cyber EV trucks, and even he was saying to me that like it was running for 3 hours, and he said you could touch the flexes and they're warm. But you get that on a lot of high current using equipment anyway. I remember running VSDs and tunnel fans on the underground. The cables were warm to a certain extent, but that's quite insightful, actually, to be honest with you. One, because my maths is terrible. Two, because I feel very rusty, because the last time I did maths was on my battery storage. And three, because it's very clear that there are, as you've both said, there are formulas for the reactance and magnetic effects of DC. And we've just gone with the Janet and John version rather than a more complex version. So young apprentices, this will be the norm. For me, I definitely need to redo I need to do it. Last design course I did was 2400. I need to do my 2396 review at some point, dude.
Yeah. Well, I mean, I've delivered this course a number of times to designers and to guys who, very competent electricians. If they do the combination, which is often what I end up doing, it's 6.5 hours of assessing. Because there's written papers and then there's projects, and they kind of every time they go, oh bloody hell, they're kind of knackered out of it, but they feel so proud of what they managed to achieve. And everyone said it's it's a tough course, it's a hard course, but they felt that they got a lot out of it because it helped them understand the regs better, it helped them understand design better, just helped them apply it.
I think one of my guys is on your course at the moment anyway, because I kind of
2396
pumped him your way. Yeah, Perry.
Yeah, he's doing those at the moment.
And the thing is, I did my 2400. I remember doing it at Steve Willis Centres, and it was the hardest course I think I've ever done, because it was like doing your, show my age now, 236 Part 2 in 5 days, rather than doing a year's worth of college in a week. And it was I remember every day going home, headache, brain melting, but by the time I got to day 5, my brain was like, I need more of this is good. Give me more knowledge.
So if anyone is on the 2396 at the moment, or if they're doing one, the biggest issue that you have with that is your exam. A lot of people don't prepare themselves to sit down at 6:30 in the evening and write straight for 3 hours. 2.5 hours in, they're
exhausted.
They completely exhausted. So I open my center up, but I literally say it's like a clinic. You can come in, you can not come in, whatever. But if people are in my center on the day of the exam, come 2 or 3 o'clock, I say, look, get out of the room, go downstairs, have a nap, chill, whatever. But you need to switch off, And if you're doing a day's work and then you do that exam, you're going to be exhausted. You'll know how to pass the paper, how to pass the questions, but you won't have the energy and you won't have the concentration, and everything will annoy you, and you'll get annoyed with yourself, and you'll give up halfway through.
Because the last exam I did, which was like handwritten, I actually found that my hand was cramping up because I'm not used to writing for more than 60 minutes.
I've reported this into. EALs is a very different arrangement. The exam can be done any time, and the timing's a lot better. But the City and Guild one that everyone likes to go for, they've got to tweak it a little bit. 3 hours is too much. There's the first half an hour of those 3 hours is actually on one scenario. Then the rest of it is just really about your regs knowledge. That's all it is. But it's not what are the regs. It's why are these the regs? What is happening here? Explain this. And it's just exhausting having to do that. And there's just 1 or 2 questions too many. It goes on for another half an hour or something. They need to do something, because most people who are unsuccessful, it's not because they don't know it, it's because they aren't preparing effectively for it.
That would be interesting if I sat the exam now and they were asking why the regs like this, because I might tell the truth.
Oh, yeah. All right. So that was one interesting area, but the other area is the way these things are having to be installed with regards to planning and installations. So here's an example: grouping, spacing. Yeah. So this is an example from an installation, large scale EV. We have 12 ducts, and these are 200 mil center apart. So it's about, if you calculate, about a 75 mil distance between them. The wine regulations, from a groupings perspective here, wants about a 0.64 or so factor for the grouping of the ducts.
Ooh.
And when you're talking about cables of this magnitude in size, it's not workable. So what they do is they kind of have to play with the data and go to another method. You see? So if we just strictly follow 7671 with a soil thermal resistivity of 2.5 as a default, we won't work anywhere. We have to go and explore the soil. We may have to change the soil conditions to improve in a controlled way to actually lower those thermal amounts.
Just on that. So I'm currently installing new ducting into a railway platform, and we're using a new system called a multi-duct, which is rather than having 6 150 mil ducts all spaced out and all the rest of it, because of the amount of material and spoil you have to take out, part of that sustainability drive, they've now got a duct which is like a post box with 6 compartments, and it's literally called a 6-way multi-duct, and the railway loves it now because it saves on material out, backfill in, But yeah, do you know what about the grouping factors?
I'm going to say,
That does change it. Yeah,
is it one duct?
it's one duct. It's
Right.
I'll get you a photo over the weekend. I will get you in fact, I'll get you a photo tomorrow.
Yeah.
But it's one duct, and it's designed to reduce the carbon footprint of duct installations.
Do they put just one duct in, or do they put 2 or 3 ducts in?
No, just one, but it's
Just the
got
one,
6
good.
ducts inside the one.
Inside the duct. Okay.
Yeah.
And is
so
it just one cable per duct in the duct?
It's whatever you want. You can have fire alarms in one, you can have comms in another, you can have power in another, you can have earth, whatever you want.
Because that's
It's a
another
standard
interesting
thing on railways. But
that's another interesting thing that we come to is the question of do you group ducts or do you group cables in ducts?
yes,
both?
that's a good question.
Or both?
Well, both technically in this case.
Yeah, well, that's what the reg says. We actually have to multiply the two grouping factors together. We find the grouping factor of the group of cables in the duct, and we find the grouping of the ducts, and we multiply them for a worst case scenario. So all of this stuff just makes it significantly more challenging to have a compliant design.
I've not seen that in the design software.
It's in there. It's in the regs, mate.
No, I know it's in the regs, but is it in the software?
I would imagine the software would take that into account. You'd have your grouping. You probably put CG in, and then I would assume that when you say the ducts are X amount apart, it should coordinate two factors and create a new factor. Does it create 2 CGs or 1 CG that changes as you add 2 grouping scenarios? I
need to check.
Yeah, interesting.
Yeah.
So this is pushing into the area that I found quite interesting when I started this, and it was about getting these cables under the ground, looking at soil thermal resistivity. For anyone watching this, obviously, we're not talking about resistivity as conductor resistance or cable resistance. We're talking about thermal resistivity. So it's the barrier for heat dispersing from a conductor. It's not about earthing where we look at trying to get a nice low earth electrode resistance. We're looking with thermal resistivity here about can the conductor give off heat in the immediate area around it. So this is where I started to look at the data that was being used by other manufacturers of cables and where they started to say what their cable sizes were. And we found that they were using some other calculations that aren't 7671, but they both work to the same 60287 ceiling standard or starting point. Okay, so 60287 is obviously that main standard that no one's ever heard of as an electrician. 7671 takes that and does a very conservative effort, whilst these ERA calculations that are used in this sector, in other sectors, have a much more specific use, and we get very different cable ratings. So, for example, 7671 gives us a unit of 1 for 2.5 Kelvin as a soil thermal resistivity. It's considered like a global value for 60364 standardization, basically, because that's what that number's come from, where they standardize, So we just got that with an air ambient of 30 degrees and a ground ambient of 20. Now 60287-31, which is obviously a local standard under 60287, there's an area in there for the UK. And in the UK, it recognizes the thermal resistivity of the soil to be typically, as a bit of a brushstroke value, to be about 1.2, which is a lot cooler. There are different materials mentioned as well in 60287, such as chalky ground, or if there's a different level of black backfill. But basically, it hovers around the 1.2. It doesn't have any distinction for seasonal variations, and it has a cooler outdoor ambient and a cooler ground ambient. Now, in the 60287, there's a descriptor of the weather conditions that gives us these values. And this is a little summary of what this table says. And this data is also, if you've got the book, this is in here in Paul Cook's commentary. This data is in there.
Paul Cook's commentary?
Yeah.
Cool, that's an old book.
Yeah, it's in there. So this is from 60287. So it says that if your thermal resistivity is between 2 and 3, you're between dry to very dry soil conditions with seldom or little or no rainfall. 7671 puts us in the middle of those two. That's what it claims the UK is.
Right.
Whilst actually 1.2, which is 60287, says we have regular rainfall and we're moist as our main direction. Okay. Now, there are very dry summers and there will be dry soil conditions, but it's most likely that 1.2 is a more approachable value.
It's 2.5 because it's worst case scenario when we have droughts.
Conservative.
Yeah.
It's the conservative approach.
Okay.
All right. So this is obviously the impact of soil resistivity. So you can see here you've got conductors under load, and when there's a 1.2 Kelvin, the actual immediate warm areas just around the conductors, because they've been able to give heat out into the soil. Whilst if the resistivity goes up and up, they keep the temperature. So it has a significant impact on cable rating because the soil resistivity impacts heat dissipation. So there is a little bit in the 7671 when you're looking at cables buried in the ground, where it says about cables being buried in the ground. It says under the reference method, in buildings or around buildings. That's suggested to mean that that's what it applies to, because if you're out of buildings, you would probably lean more towards the ERA calculations. And it does say in Appendix 4 that if you have specific data, more on thermal resistance, the ambience, the depth of the ground, if you have more specific data, you can use the ERA calculations instead of 7671. And this is a little comparison of the two. Very different data streams. Okay. There's a part 3 and a part 5. The part 3 is thermoplastic. The part 5 is thermosetting. There's 9 different reports in the ERA calculations for different, all sorts of little shenanigans and calculations. Quite an interesting read, actually. So I got 3 and 5 sorted out when I started this, and I went, okay, let's look at all these different data inputs. But it was actually because of the challenges that the designers were having with 767 that made us look into this. And we looked and we found this press release by Prismium, which also mentions about this. So this is from Prismium Group about why they state their cable ratings are different to 7671. And they say in this release, I don't know if you can obviously read this on YouTube, but they say that we actually don't follow 7671. We follow the ERA, which is both aligning to 60287. That's the key thing. Both 7671 and the ERA calculations align to 60287, but 767 is under a conservative condition, whilst the ERA requires an awful lot more specific control of the conditions through the seasons. But if you can get those controls and you can guarantee that condition of the soil, you can get a much better rating in your conductors. And so this is just a release that kind of explains that. And obviously manufacturers want to do that because they can then say their cables carry more current.
Wow.
You know? So installation depths are different. The ERA also specifies between duct and buried direct. Significant improvement if you bury it directly. Yeah. Obviously, most people put ducts in for the sake of civils and cable pulling. But that's the main thing here. These are the two different approaches, but they both are matching 60287. They're both using 60287, but one is conservative, which is the regs, and one is much more precise data input. Now, the regs is always that fall back on the regs and you'll comply. And it's recommended for most designers to comply with the regs. So you have that conservative angle. But with large scale design, where we've got huge amounts of demand, huge amounts of energy, and we've got these grouping factors, and we've got planning trying to squeeze us all in such a small space, 767 just says go fish very quickly. It doesn't work because we end up with very uneconomical solutions for cable sizing. So they've gone down this direction of using the ERA calculations, but even then, it's still not enough. It's still not enough. Here's a little summary of the comparison between the two. So conductor size, what 7671 says they can carry, and what the inducts and the buried direct of the ERA calculations say they can carry. So,
wow,
this is one of the things that we discovered, but there still wasn't enough. It still wasn't enough because of the challenges of the way large scale EV is installed. Because you've got 12 ducts, you may have one with two 240s in, and then one charger will be pulling two 240s in parallel because it's actually taking a 150 and it's pulling 360 through it from two power boxes. So there's still huge stresses. But what we don't know yet is if the way they're being installed will survive when they are actually finally loaded, because they're not loaded yet.
Yes, okay.
Yeah, the future will be, hopefully we'll get away with it. But there's a lot of designs going in with an awful lot of grouping. We've discussed in the classroom, could we have things like cold loop systems in, or to take the heat away, some heat sensors on the conductors, and then a cold loop which will help cool down the ground, or all these things. Because obviously, if the ground gets really hot, it dries out, which makes it so its resistivity go up. So try and find ways to create climatic conditions in the soil. There are all these things that we may have to go back and do, but we won't really know until these things are put under a significant amount of demand, which isn't yet, because we're not all in EVs yet.
But look at the difference, though. I mean, the 185, the 281 amps and 7671, 458 Berry Direct. That's incredible. The thing is, it just reminds me of DNO cables. Some of the DNO cables that are tiny, especially the old Pilk stuff, they're tiny, and you look at the power that's put through them, and you go, how do these things not melt? And they don't, because they're Berry Direct.
Yeah, and we've had a few DNOs on the courses. We've got this I should have brought it into this other cable that they have. I can't remember what it's called, a hexafoil or something, where it's actually arranged in a certain arrangement where it just gets an awful lot more current through it because it's a specialized cable that they use from load centers to EVSEs as well.
Trefoil, is it?
No, there's another word for it. I'll see if I can dig it up.
Is it Wavecon or something?
Wavecon. I think it's Wavecon. Good old John. John's filled with information.
How did I not know that he would know that?
There must be a lot of crossover between this and LV distribution, surely, because it's, obviously DNOs or whatever they call themselves this month, because it's DSOs now, isn't it? They've been doing like cables in the ground which are massively loaded for long periods of time forever, for the sort of last 100 years plus. So surely there's a whole load of wealth of information there which could apply to this sort of thing as well.
Yeah, I'm just looking in my folder. Keep talking, you guys. This is great. I'll see if I can find something on it. And
the same with all the stuff about the reactants, the cables and things, because again, that's all LV distribution and HV for that matter as well. So again, it's not new information as such. It's just new to these particular types of applications, but the general concepts are there.
I don't know if I'm just thick or I didn't pay attention in college or they just didn't teach it. But the older I get, the more stuff I see out there, the more I go, we were never taught this when I was in college.
No.
But yeah, I've spoken, and having worked for a former DNO, as what they ever call themselves this month, the sort of the normalization of these common sense, Berry cable direct, etc., contact with the London clays and stuff and the cold moisture. And it's going to carry more before it burns out and melts and bakes the ground. And we've even seen pictures where you've got snowy ground and the cables are so hot, melting the snow above it. It's fascinating. It's fascinating stuff. God, we didn't do any of this on my 2919.
No, doesn't touch it at all. The 2919, but to be honest, and the 3.4, it's all about, well, the 3.4 now anyway, it's all about earthing and protection, really. We on the large scale we have to cover that, but we also have to cover selection. We have to cover accessibility, which is a huge issue, which they're still getting wrong. A lot of the big people aren't actually getting it, even with the latest pass 1899. They're still not fully doing it. A lot of charger operators and manufacturers aren't even making them accessible still. So we have to put all of that in there as well. It's one of those spaces where we won't really see how things are going though until we have a significant amount more demand. John, I remember when we were at Paul's funeral, I said to him, John, you've got that whole place all to yourself, and I think it was 150s, and you said, yeah, but I can only charge at 80 kilowatt or something. You said,
yeah, my van is I don't actually know what the maximum charge rate is, but I've
Yeah.
only seen it up to about 80.
80.
And the thing is, even at 80, it only stays there for about 5-10 minutes maximum, and then
Yeah.
it starts to drop off.
And that is the thing. An awful lot of these early cars don't have that demand. They don't have the technology for that demand. But we're getting obviously the latest Porsches, the latest Teslas. They're very much hungry. They're very much hungry because they're trying to obviously push and push and push and push and push. So a lot of this stuff that's been installed and open for a couple of years now is going to be soon under a much larger demand than it's ever seen before.
Yeah, because they even certain cars that can charge up at like 300, or they can claim to. Yeah, if you arrive there at 10% and the battery's all heated up and everything in advance, and you plug it in, yeah, it will go at like 300, but not for very long. So you plug it in, it's like, oh, it's 300. Then, oh, it's only 240 now. Oh, no, it's only 180. So certain vehicles will carry on at a large rate, but an awful lot of them, it's only for a very short time, and then it immediately drops back. So, like I say, it's rare that this equipment is even put up anywhere near its maximum at the moment.
And this is a concern. I had a chat with the IT about this, as they, because they asked for comments on how this course is going. I said it's good, and I gave them some heads up as to a lot of their designs. 7671 was kind of left at the door at some point because they had to go down the ERA direction, and then when they get to, and I've got a drawing here of an installation. Can you see this in the share?
Yeah.
Yeah. So this is an installation that was drafted for being put in on a motorway. And you've got here obviously you've got the ring main of the HV coming in and then leaving. You've got the HV that goes onto the other side for the southbound or the northbound. You've got the AC. These are the AC ducts. So if I go to E here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them.
Wow.
You see? So right now they're probably barely ever on to any potential. But if they get put onto a potential, there may be some issue. Hopefully, an awful lot of these will get away with it. But right now, though, we don't know. It depends on how much they demand, how much more they decide to stress out, because they're constantly adding power. One charge point operator, for example, who I won't name, but what they did is guys put in an installation just like this. They put in the power cabins, they put in the charge points, and then the charge point operator who they handed it over to changed the power modules in the power cabinets from 30 kilowatt to 45 kilowatt by themselves to make the chargers more powerful. But what they did, the way they achieved that is they changed the voltage, the DC voltage they drove up, and they drove the voltage over the rating of the voltage that was in the cable for the DC ducts. And they burnt the cables out.
That's
I believe they promised not. I believe they promised not to do that again. But that's that's just the thing. There's this hunger to be powerful, to be quick, to then get people to buy EVs because they can. We're talking here about rapid charging now. We're not talking destination charging. So the main point of the large scale really is to focus more on the rapid charging. Large power, quick, get in, get out. They want you to basically be charged up by the time you've gone in there, bought yourself a coffee, and used the toilet. They don't want you. They don't want you more than 40 minutes. Because this is expensive infrastructure, and they want every other car to need to charge or to use this technology in the future. So they need you to get in, get off, get on.
Isn't it limited as well? If they're all the bays are charging as well, it will limit each one's charging capability.
It depends on how they're currently connected. So, for example, these ones, these were. Let me just double check these. These are 175s. Okay, so these are 175 power cabinets, but each one has 2 DC circuits to them, so you can actually put 2 175s feeding one charger. All right. So what that means, and I've got another drawing here of the other side of the motorway, is when we get to the grouping of the ducts, we've got an awful lot of grouping going on here. Just wait for my Adobe to wake up. Because of all this grouping that we've got on the DC, wait for Adobe to. These drawings are quite in depth
and big.
So we've got here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 24 ducts in this
But you won't
section.
get much snow settling on that section above.
Yeah, the voltage thing is quite interesting because this is why a lot of vehicles can't charge at the rates claimed by the manufacturer, because you've basically got 400-volt vehicles and 800-volt vehicles, and yeah, you can get the high powers on the 800-volt system, but if you go to charge only 400, well, good luck, because it's not going to happen.
No.
So this is sort of leading to customer disappointment when they buy their vehicle and it says, oh yes, it will charge at some massive rate, and they go to chargers at only 400 volts, and oh no, sorry, we can't do it on this one because of obviously limitations. But when you think about it, you've got an 800-volt battery in your car, those DC cables are going to be pushing out 900 volts plus.
Yeah,
that's a lot of voltage.
That is a lot.
So,
and the thing is, a lot of cables aren't. A lot of the DC cables that were going in weren't for that. So they had to change the cables, and a lot of people have had to change the actual specs of their designs for these cables because the charge point operators have just been pushing the limit and pushing the limit and pushing the limit again and again. My Adobe's just.
So who designs this stuff then? Who comes up with these designs? Is this the manufacturers of the charge points? Is this just a designer we get off the street? Because I'll be perfectly frank, I've seen EV charger installs, and I've never seen the level of calculations, formulas, and designs that you're talking about today. So this, for me, has probably been the most learning and insightful podcast we've ever done.
They've. I mean, from my experience, I mean, I've worked probably now with about 30 different guys who are, companies who are doing this, big scale. Big scale. There's 4 or 5 key points of software they use, but a lot of it is, I wouldn't say trial and error. A lot of it is sense checking. I get a lot of emails, kind of sense checking designs, giving a bit of input, because a lot of it is, again, if you do a little, you're talking about here, you saw that cable run. I mean, you're talking about 50 meters of a 240mm cable. If you're going to say, well, in my adjustment of calculation, I'm going to now do this little factor, which is going to make me require a cable twice the size, you're not talking about an extra few £100. So they have to constantly try to design it down and get what they can in those cables, and they have to find ways to kind of understand how they're going to be okay. So in a lot of the training, we go, okay, well, look at the thermal limits, look at ideas about, as you say, the snow will never dry, settle on that area. We need to be cautious as to how warm these will get when they are put under this demand, but they're not under the demand now. Which is the underlying concern, is we put these things in, we commission them, we turn them on, but really we won't know, until we've got an awful lot more EVs out there. Right, is that now behaving? Yeah, it's now behaving. All right. So yeah, this is the other side of the motorway. So we've got here in this section, we've got 24 of these, because each one charger gets 2 ducts with its own DC circuit. So each charger has 2 DC circuits, because each one charger is fed by 2 cabinets. Because as you asked, Paul, I mean, how much they can take. One charger can be fed by one cabinet, or if there's no one next to it, it can use the other cabinet. So they can actually link at the cabinet and then feed both those circuits. And if someone comes and plugs in, it can then communicate that to that cabinet, and it can then disconnect from that link, and then only one of those circuits will be fed. So they have a good way of distributing the power, so you can get the gains and you get the maximum that's there potentially. But it's why a lot of people, when they go to EV, they won't park immediately next to the other car, because they know that those 2 cars are going to probably share a cabinet or 2 cabinets. They'll often park further apart. Same with AC fed ones. AC fed ones are much louder and much noisier, much bigger, but the same thing. They'll have power modules internally, and you can have them so that all the modules and power modules go to one plug, but someone else plugs in. It can then look at that, and it could be a first come first serve. It could be a 50-50 share. It could look at the battery status. So I could plug my car in at 70% charge and have 100%. Someone comes in that's got 20% left, it can give them 75% and give me 25%. So the charge point operator has these controls. Manufacturers put some basic controls in there, but you can use software for better controls about how the power is distributed. The priority will always be try to give everyone the maximum potential, but always make sure there's enough. But what we don't have, as I say, we don't have enough cars. When we have more cars, we're going to put more thermal load on these systems. And right now, they're not necessarily grouped very well.
So,
Very well.
question then, you mentioned about software and stuff controlled. Does any of the software have any SIL integrity rating on it, or any design checks for the software side of it? Any safety checks?
I've inquired with 2, and they
Yeah.
said yes. And I said, does that mean I can say it's a safety? And they said they couldn't confirm. Because I've always said this to the guys on the courses, we have to be very cautious if we're going to use safety for the purpose of protection. You know, it when software takes over as a protective purpose, we've obviously got extra work to do. And the couple that I have contacted have said, yeah, it does this, it does this, it does this. So can I sign it off as my protective function? They were, they were a little bit loose with that. I'm sure there's one somewhere that has, yeah, they say it's fine. But there's an awful lot of load management. There's an awful lot of hope that things will work well in the future. I've not seen much in the way of thermal management. For the cabling itself, because I've said to a few, could you put in a temperature sensor? Those hot connects. Could you have like a temperature sensor that works on that, where it works at the temperature of the conductor? And it's not hard to do.
Nope.
At all.
External sticker on it just to check whether the temperature exceeds.
Yeah. But even if you don't want to stick it because you're leaving it somewhere where you're not attending it, you could put a little temperature sensor, a thermocouple or something, down the duct on the cable. And if that temperature gets to a certain temperature, it can then hit an alarm. It can then talk to the management, because there's a monitoring system. All of these chargers have their own separate AC feed because they've basically got their own control circuits. And you can have a sensor that will then create that alarm. Right now, that's not on the radar because nothing is being powered up to its potential because people aren't queuing up to charge. But we may get there in the future. So it'll be interesting to see what happens in the long term. Someone is going to innovate a method of thermal management. Somebody needs to implement a method of thermal management, because right now the thermal management we use in 7671 in design is grouping our ducts and putting factors in. They're not doing that in the large scale space because they can't. They can't obviously create trenches that deep and that wide to space those apart. For there to be no factor, they've got to be like nearly a meter apart or something. So they can't practically put them apart far enough for there to be no factor, and they can't afford to put in factors.
Well, my brain's knackered.
So again, 7671, there's a little bit of a merry-go-round.
So large scale EV basically can use some of the intent of 7671, but basically it gets left at the door.
It's 7671 needs to go into this area, and it needs to give all of the designers, all the design houses, all the contractors better guidance and confidence, whether it goes and gets the data from ERA and goes, yeah, we can use that. But you must make sure your soil resistivity is identified. You must make sure your depths are verified. You must make sure the conditions of the soil are guaranteed through the variations. Fine. But it needs to give some workable method, because if it says, oh yeah, space per meter apart, you're fine. In this makeup, you can't do that.
You know what I would do, Dave? I'm not suggesting that the IET do this, but I would obviously update the wiring regs, but I would probably create an on-site guide for domestic, commercial, and industrial.
Yeah, maybe.
And clearly segregate the on-site guides into specific. Even if you did one for EV, one for rail, one for water or whatever, but you actually gave people more information of how to implement and manage the risks and challenges of certain sectors and specifics, and because it's just not enough out there. But
no, and again with this sector, I mean, they're now in the megawatt territory, so we are looking at trying to find ways to put in distribution above ground on like rail and racking and things to keep the thermal limits within control. But that's okay for a dedicated megawatt system. But this thing in the future, when it's going to have a much larger demand, you could say, it's only going to be a short period of demand. But if the cars come and take the full potential capability of these powers, of these the power supplies, then there could thermally be some challenges on some systems. I'm sure we'll get away with it with most. But there are design limitations in 7671. Put it that way.
I think that's fairly evident and clear. Is there anything else you would like to give us on the large scale EV, or is that enough for today?
I think that's enough for this. It was just mainly an interesting point about the fact that 7671 gets to a point where we can't use it. That's mainly what I wanted there. There's areas of 7671 that we have to leave 7671 behind. With the design, we have to do bits we've not done before. With this arrangement here, we need to do things we haven't done before. There are many other areas of very interesting, and obviously looking at the technology now, there's so much going on with regards to the plug connections, with regards to the cable types, with regards to the actual way things are being communicated. There's also so much going on in the domestic sector, to be fair, and the small commercial with regards to EV. But things are moving so fast, we're not getting enough time to kind of catch our breath, and
that's what scares me.
And figure things out. And my concerns, and I had this chat with one of the guys at the IT when I saw him at CEF Live a couple of years ago, is a lot of these designs aren't going to be thermally loaded for a number of years, and some of them may start to actually struggle unless we react or we provide some further guidance.
Well, of course it will. With anything new, something has to go bang at some point. But
there's an awful lot of money being thrown at this, and again, many of these have had to be reinstalled already. Many of these have had to be reinstalled because they weren't working. There was insufficient supply. The software didn't work. They didn't have enough network, or the demand of it wasn't big enough. They had a bigger demand now. I've got one dropped off at my center that was beyond requirement anymore because it could only produce 22 kilowatts.
Only.
And we're just moving too fast.
We are indeed.
But that's the target we've been set.
Right, we'll stop sharing your screen and we'll wind this up. John, is your brain feeling slightly cooked?
Yeah, there's a lot of information in that one.
Yeah, that's a hell of a lot. Dave, you've absolutely won. So I'm going to offer John a challenge because, John, you are an EV driver. So I want you to somehow work out in one of your own unique YouTube videos to get your van to charge at 1.21 gigawatts. And then we can go back in time together in your van as a team.
Can your van do 88 miles per hour?
Yes, it can.
Oh,
that's
only
John
on a test track,
day.
Of course. Only on an approved test track off of public roads, of course. But
of course, okay. Having been in John's van,
you can vouch for that.
Yeah. Yes, and when you were in my van, it wasn't even set on high power either. So
no, and this is why I think John would make an perfect extra in the Fast and the Furious movies. They wouldn't even need to direct him; they'd just say, "Get in a van and go for it." And Vin Diesel would be very envious at his skills behind the wheel. But yeah, okay, all right. Well, there's a hell of a lot to unpack on that one. Well, we did say we'd podcast random electrical things, and that's very good. So Dave, if people want to get in touch with you and they want to sit on the EV courses, where can they catch you?
Just Google Sparky Ninja and you'll probably find something that links to me. You'll find a website probably, and the courses are on there.
SparkyNinja.com, or on all social media platforms. Get in touch and register to do one of his training courses. I'm going to do some training with Dave over the next couple of years, and God help.
You may be interested to know I've actually arranged with Hager to deliver this course at their site in Telford, because they've got a little site in Telford. We're doing it in May, where we're also going to do a factory tour and everything.
Oh wow!
Yeah, so it's something that we've just sorted out with Hager. I haven't even announced it yet, really. I'll put a thing out next week about it.
Okay, well you just have, but there you go.
Just have. There you go.
Right, we'll end this up. Final thoughts, John, Dave.
Well, I think, as I said at the beginning, BS7671 is in need of a bit of an overhaul, and there's a lot of stuff now which it just can't keep up with, all this new stuff coming out, and there's stuff in there which should have been there before. So just going down the route of BS7671 Volume 1 and Volume 2 and Volume 64, isn't it, really? So we'll have this whole shelf of nice books instead of just one. So it's going to happen at some point.
Dave?
Well, I mean, I think I've said a few times here that there's concerns about demand in the future. But leaving this to the side, I think overall we are very much going into the territory, and I think I said this in a previous podcast, where we're going more into becoming technologists, and we're relying on an awful lot of other technical things with regards to the way we're designing systems, the way we're establishing protection with renewables and stuff. But from my experience, especially my experience in the training sector and in the colleges, we are so far behind. And the answer can't be to just keep buying books. We need to have some other solution where we're kind of being given support in that space, because it's just not enough of it in books. The books are great. I like books. I've got books everywhere here. But a lot of Sparkies don't like buying loads and loads of books. They like buying a couple of books. The one book that we have to buy, it's not a great novel. It could do with a little bit of a refresh, but we understand the whole history and the standardization and the processes. But there's an awful lot of technology coming to that now, and it's just gibberish if it's not properly interpreted and properly supported.
So kind of a valid point, really, isn't it? Is we're becoming technologists. The end loads and the end equipment have got very finite requirements, and we've got a very stale book, which is very linear, that kind of only now is updating with clues and hints, like a choose your own adventure book as to what could come, but it's down to you as to how it comes, and you're just like, yeah, it's definitely a weird one. But anyway, that's large scale EV, folks. A brain melting whistle stop tour through it. Lots of new formulas, lots of thoughts, lots of feelings on it. Get yourself out, get yourself retrained for the relevant level you're at, whether it be domestic, commercial, or large scale industrial.
Yeah, we are going to do
we
are going to do a podcast soon talking about training, aren't we? And apprenticeships. So look out for that. There'll be one coming up, because we've got lots to talk about there.
We've got a lot to talk about, a few things now. I think it's fair to say time is, time resurrects some interesting conversations, but that'll be for another week, I think. So, other than that, I'm going to wind this up now. So, to everyone listening or watching, thank you very much for listening. Thank you very much for watching. On behalf of JW and Dave, take care of yourself and each other. Bye-bye.
Bye-bye.
Bye.